maybe we can just start with a quick introduction of you, Johan. So a little bit who you are, what you've been doing, um, everything.
Okay, so my name is Yohan Aji, and I'm 17 years old. I'm French. I'm living in Grenoble in the French Alps. So yeah, basically a bit in the south of France. And my passion, I would say, is to make things fly and to find problems, find idea, and give them life. And the last project I'm working on is Earthworm. And so basically, Earthworm is a um, autonomous guided parafoil recovery system. So the idea is that it's a tube that you can drop from almost anywhere, and it will autonomously deploy a parafoil wing and steer it to given GPS position or anything. The idea is a bit to create a platform that you can use for different projects, but it's also for me a project to learn new things and fail, test, learn, and retry.
So how did you get to this project?
Well, it's there was multiple steps. The first step is that I like things that can fly. So as you can see in my background, I was flying already as airplanes and drone, etc. And one day while I was in high school, our physics teacher came across and asked if someone want to build a CubeSat, not a real CubeSat, but like a mock-up, so to learn or to code or to mount something, etc. And we did this project. It was really fun. And at the end, we were multiple guys like we need to do something else. And one of the things high school can do is to launch a weather balloon with like something to measure the temperature, something to measure the pressure, and so you can learn a few different things. And I discovered that the problem with this kind of project was that at the end, there are high probability that the experiment is lost because basically when you launch a weather balloon, at the peak altitude, the balloon is exploding and then it falls down in a non-guided way with the wind, etc. And so it's difficult to recover it. So my idea was that if one day we do this in our high school, we have to have a system that is able to guide the experiments during the descent. And so this is where the project started. But if it was in summer 2019 and we are in 2021 and the project is still not yet fully operational. So yeah, it was actually more a learning experiment and a learning adventure than something really functional as far.
So, but 1.5 years is definitely not a very long time in the aerospace sector. So I think you're still doing very well. Because I also saw quite some videos of drop testing, of various testing of the system, right?
Yeah, well, I would say that the hardest thing on this project was to get the parafoil to deploy right, because as you guys I think know, it is really hard to deploy a parachute when you know nothing about it, and there is a lot of failing involved. And the main thing is that basically when you fail with a parachute system, well, often everything is lost. So it's also hard for this reason. And so it took me almost 8 or 9 months to fully understand how to deploy the parafoil correctly. And the only way to test it was like just take a drone, attach it, and drop it and see what's happening. And maybe 50% of the time, it ended up with the system just destroyed into the ground, but it always ends up working if you solve all the problems that you have to solve. So yeah, I'm doing a lot of drop tests still, less to test the deployment of the wing, but now what is to be tested is the autonomous pilot, like how you fly from point A to point B.
Yep.
And there is still a lot of work on this part, but at least now the chance of the system crashing into the ground are limited because the deployment of the wing is reliable enough.
So you mentioned that about half your experiments ended with a hard landing or a slightly harder landing than expected because the parachute didn't deploy. What kind of failures did you have in this deployment?
Well, the first types of failure at the beginning were about the spiking of the parafoil or paraglider because you can't just push it in a bag and then take it out of the bag. It won't work. You have to pack it in a way that when it's out of a bag or anything, all the lines are under tension at the same time. Tension at the same time. And so this was the first thing to understand. Then there are more or less developed techniques to pack a parachute, more or less hard to do. And at the beginning, we started with high aspect ratio paraglider wing, and it is obviously more difficult to deploy a high aspect ratio wing because you want it to expand really fast without tangling into the line, etc. So it was a bit of a mistake to start with this wing, but it was the only thing we had. It was like a RC paraglider that you can bought on internet. And what changed to solve this problem was when I discovered that it is not that hard to sew your own ram air canopy. I mean, it do takes a lot of time, but if you are motivated enough, you can do it. You just need a sewing machine and some fabric. So this is something I started, and basically when you have a ram air parachute canopy, the aspect ratio is way lower. It's almost a square. And so it is way easier to deploy. And this was the first problem. Then the second problem, where there was a lot of failures, was, oh, do you deploy the wing? Because you can't just have the wing like floating into the air, and when you want to use it, you fall and it is inflating. You have to have it in a kind of bag, a deployment bag, a D-bag, and you need something to pull the wing out of its bag. And I knew about drag chutes, so small parachutes that I used to pull the bag out of its bag. So I started to sew a few of them. So basically they are really simple, but the idea was, so there is this drag chute and he is pulling on the line on the D-bag, and as soon as the D-bag is released, the wing is pulled out of the bag. But the problem was that under the drag chute, the system is falling really fast. So if there is any problems about the D-bag being released or the wing getting out of the bag, then you're just hitting the ground. So at the moment you're releasing the system from the drone, you have no security, you have anything else. You have to deploy the wing, and this is not really great because obviously when you design something new, it won't work the first time. So obviously the first time it failed, it was an epic fail. Just went to the ground like that. And the solution to this problem was to have a bigger drag chute so that whatever happens, if it falls under the drag chute, there is no big problem. But then the problem is, if you have a big drag chute, you won't be able to fly your wing properly because the drag chutes will still be flying around. One solution could be to say, well, we're just gonna leave it fly on its own, and it will land anywhere. And this is what is done, I think, on bigger mission, like what SpaceX is doing. Is doing with dropships. They are just disconnected, but I can't really do that because it will mean that every time I am making a test, I have to have a new dropship.
Yeah.
So I had to design a dropship that could be both big and small. So big before deployment, so there is no problem if everything fails, and small after deployment, that the wing can fly properly. And at the moment I had this idea, it was like, oh, that's an incredible idea. I'm going to sell thousands of them all over the world, but it already exists for skydivers. And the idea is that it is still the same idea of dropships. So you have a first part of fabric, and then a second part with like small holes. But I'm gonna have to step back a bit. There are two lines in these dropships. So, and the trick is that there is one line into the other line, and if you release one and not the other, you're going to be able to disable completely the dropship. And so there will be almost no drag force anymore.
Yeah.
So this was really the idea that boosted the project. And as soon as this started to work, the deployment was almost working properly.
Okay, so when you fixed the problem with the drogue chute or the pilot chute, the inflation of the parafoil was successful.
Yeah, there was a few other problems because as I said, we went first with the paraglider. It was not working. Then with the parafoil, smaller aspect ratio, it was working, and then the parafoil was flying great, but it's obviously flying not as great as a paraglider because of many factors. Like, if we can only speak about the aspect ratio, but there are many. And so I wanted to go back to the paraglider wing to have more flight capabilities. And the thing is, doing all the tests I did with the RAM air canopy, I had a bit more knowledge about how to pack the parachute, how to put it in the bag, etc. So I didn't have to change so many things to go from the RAM air canopy to the paraglider wing. I had to redesign a bit the deployment bag, but yeah.
The idea is the same. Yeah. So how many test flights have you done between the first one and where they became successful, right? In succession.
I mean, there was a bit two types of test flights. So one thing about this project too is that I live in a city, so there aren't that many fields where you can go with a drone at 100 meters, and so I did big drop tests, and you can find those drop tests on YouTube. And I also did smaller drop tests in a small field near my house, and I would say that maybe there was about 10 drop tests before things started to work. But maybe you are thinking, 10 is not that big, but what I have not said yet is that between a drop test, there was often like 1 month or 2 months of like, how am I gonna solve this problem? And then before the drop test, and before every drop test, I was, this time it's gonna work. There is no way it doesn't work. And there is always a small problem that goes somewhere and that makes everything fail. But now something I've learned a bit is that if I design something new and when I test it, I see no problem, it's not that good because it means that I have not yet found all the problems that will happen. So I am less afraid, and now it's a bit an habit to when there is a problem, because okay, now I know that this is a problem, I can solve it, and then I have a larger field of view of what I am doing.
Yeah. I mean, every failure or every problem that you encounter is also a learning moment, right? You can improve the design, but also your own knowledge for anything in life in the future.
You usually feel very damned about what you were thinking a few days ago.
Yeah.
And
that's the beauty of engineering.
Sometimes you learn a lot more from a failed experiment or a failed flight than from a successful one. You might indeed find new problems with a system you didn't even know that you had. I think Thomas, we crashed quite a bit of rockets and systems in the last couple of years as well, and
well, definitely. That's why they do testing.
Exactly, and it's also what you said, right? In parachute testing, you test, especially in the drop test, you test, and if it's not successful, then you hit the ground. There's no
big payload
return to launch site button.
Yeah, and what is even sometimes more stressful is that now the wing is flying at about 20 kilometers, 20 kilometers an hour. So if there is a bit of wind, that's okay. But at the beginning, the wing was way less loaded, so it was flying more like 10 kilometers an hour. And this means that if there is a small bit of wind, you can fly. So when there was one day in the perfect weekend with all the conditions, you are coming to the test field, you have everything, and still it is failing, and you know that there won't be any other opportunities before maybe 1 month or 2 months. It is even more stressful. But then the day it starts to work, it is even more better, because you are remembering about all the time it did not work, and
then you have that success moment.
And now that's the moment I'm chasing every day, and I don't think I will ever be able to avoid chasing again this moment.
But now sorry, what you were saying, Thomas?
No, you can go ahead. Sorry.
But now you have a fairly reliable system, at least from what I see in your videos and what I get from you. What are the next kind of challenges or improvements that you're thinking about?
Okay, so basically now I can drop the system from my lift drone, and it will automatically deploy the paraglider wing, and then if I just let it fly, it will fly in straight line up to any point. But and it is doing everything autonomously. But now the thing is, how do we fly autonomously from the point we release at and to the point we want to go at? And even more interesting, how can we be sure or not that we are going to be able to reach the point we're aiming at? And so, basically that's all the autopilot stuff. And what is a bit complicated at the moment is that a paraglider is not really like any other types of flying aircraft. Aircraft, and I mean that it doesn't really respond the way you would think wing or an RC or drone will respond to command. And there is a lot of delay in the command, and any paragliders will say to you that the best way you can fly a paraglider is just giving no output. So every time you give an input to the paraglider, you are making it fly worse, and this is making all the control algorithm a bit hard, because the mathematics behind the problem are not that hard. It's just an angle between 2 points on the Earth, and then at the moment it's just a P controller. So if the error is big, then the command is big. And we are controlling all the system on the GPS course over ground, and it's a bit the only way to control it, because otherwise, if you try to use, for example, a compass, you're gonna have a problem, which is that the wing is flying in a moving air. Sometimes there is very little wind, but the air is still moving a bit. And so if you're just pointing at a direction, then you're gonna derive, and you're not gonna reach your position. So there are lots of challenges like that to solve. But the main at the moment is to make the connection between the error that we are able to measure and the output that we want on the paraglider, and the way we are controlling it. There are multiple solutions. One of them is using a P controller, like I'm actually, maybe a PD. That's something I'm going to test. And there is also another way that some people have already tested with RC paraglider, which is a bang controller.
Yeah.
So instead of doing small correction, you're gonna do tack, 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 and it will be less precise to reach specific angle, but it might be a little bit easier to avoid over controlling or everything like that. Because at the moment, one of the problems is that if you want to turn pretty fast with a paraglider, you have to give control input that, if this control input is held for too long moments, it will make the paraglider go spiral.
Yeah.
And this is what you can see on one of my last video, I think, which is that there is a flying mode you don't want to go in. This is spiral, because you are going down really fast. You don't have any inputs anymore on the GPS course over ground, because obviously you are not moving anymore. Yeah, it's a dangerous mode. So if I'm able to find a control algorithm that makes sure the wing cannot go into this mode, it will be great. But that's the challenge now. Or we go from point A to point B.
Yeah.
And maybe another challenge is that at the moment I'm just thinking about going in straight line.
Yeah.
But it could be very interesting to see if it's not sometimes smarter to go in any other ways than straight line, like in or spiral, or
so from waypoint to waypoint, or five patterns.
Yeah. And one of the problems I'm going to have also is that when you want to test an autopilot, you have to fly for long time. You can't just fly 20 seconds and say it works, because you won't have found all the cases. So I'm gonna have to conduct some higher altitude tests. But it's also something that is difficult, because you can't go with a drone higher than 120 meters in France, and all over in Europe, I think.
Yeah, I think it's the same here. Yeah.
That's going to be difficult, but that's going to be necessary too. So I'm going to have to find other solutions to test the system. And maybe one of them is on a model rocket, because that's a good solution, but maybe not yet, because we first need to make sure in any case it is safe. And also one thing I should mention is that the system is all built in a 3-inch Coupler tube.
Yeah.
So if you guys are doing a bit of rocket fly, and it is designed to fit in a model rocket, because initially the project was for weather balloon.
Yeah.
But I also learned that people flying model rockets are obviously also interested by such a system, because you want to fly home and you don't want to work for a long time to get your rocket back. It's a bit a different problem. It's also interesting. It's not the same flight strategy, and you don't have the same deployment requirements, but it's also very interesting. And so this is why the system is designed for both applications. And so one day I hope it will fly on a model rocket.
Yeah, I think I think it can be very useful for sounding rockets and weather balloons. But yeah, what you need quite often see is either you lose your payload or it lands somewhere. It takes you a lot of time to recover and retrieve it, to find it back. If you find it back, if it lands in a forest, then yeah, tough luck.
Yeah, because I mean the name of the project is Air to Home. It stands for like air to home, but also return to home. But there are many cases where you can't really return to home. Like if you launch a weather balloon and it is floating for 200 kilometers, you obviously won't be able to get back to home. But it is still very interesting to be able to avoid big roads, lakes, big forests, or any remote area. And one of the side projects that I also have is to make a software that can take 10 kilometer or 100 kilometer by 100 kilometer map, and it will search for big fields.
Yeah.
And it will take the 10 bigger fields and create a list of safe zones where you can land, and automatically it will upload all these safe zones on the system. And so you won't even have to say, well, I want to land here. It will automatically choose where the best place to land, and it will fly there.
And then tell you where it landed.
Yeah.
Sounds very interesting. So, you're going to university now, or starting in September, I believe.
Yeah.
Will this project move with you, or will this be handed to another student from your school?
That's a very good question. So at the beginning, the project started with my school, but I would say that since maybe 6 months or 1 year, it's more a project of mine. But what is interesting in discussion, I think, is that I don't think I will ever be able to work on this project for many reasons. And so this is also why I decided to publish the most thing I can. At the moment, the project is not restricted by any law, so I can publish everything I want.
Yep.
And yeah, so next year I'm going to university. I hope I will be able to continue to work on this project, maybe also as a project with the university. We'll see if it's possible. But if one day I'm not able to continue to work on the project, my biggest hope is that someone was having a bit the same idea, or who want to continue the project will have all the information necessary, all the files, all the documentation, all the problems I had, etc., to be able to continue the project, maybe in another form, changing a bit the things, but so that everything I have spent time on could be useful to someone else.
So if people want to continue this, how do they contact you, or how do they find the files?
Well, so there is a GitHub, yeah, where you can find some of the files. So what I do is that every time I have a working version, so every time all the problems are resolved with this version, I'm publishing all the files. And so the last version you can already find is the version from before the summer, and I'm about to publish a new version, I think. And so you will basically have everything. So this is the first part about all the files. And then if you go on the academy.io page of the project, there is a list of materials, and there are also all the project logs where I basically explain all the problems I had. I've also made a video talking about all these problems. And yeah, there is still a lot of work to do on the documentation of the project, but there is still a lot of things people can start to look at if they are interested. And then I'm on multiple social media. So if you want to reach out, just do it. I'm open to every proposition and every idea.
Nice. Yeah, I really hope that people continue this, or of course that you can continue it in during your studies. I think it's a very interesting project, and I mean, besides the engineering, it's just a really cool project to work on and to learn from.
And
yeah,
even
I think that there's definitely a need for or there's definitely a use for this sort of product on the market, especially for weather balloons, as there's so many being launched and just left to fall down.
Even if people want to try to start something with this project, and I'm still working on it, in my opinion, it's totally okay. Like, the more at home they are, the better it is. Like, they will find new idea, and I'm not trying to restrict in any way what people can do with what I published, and yeah, I think it's a good thing to share everything you do, because everything I learn, most of the things I learned were freely published on the internet. I've spent so many times learning things on the internet, on seeing idea on YouTube, etc., that it won't be honest if I don't give a bit back to the community, etc.
I think that's really really awesome and really good to hear.
Great mindset.
Yeah, exactly. I mean, I think transparency is very important, especially in aerospace, and especially in the parachute field where there's already so little people working in the field.
Exactly.
It's good to share the knowledge.
Yeah.
And I mean, projects like this or CanSat or any other the other projects that are focused more on high school, they're really good to bring more people into engineering. So yeah, I mean, even if it's just people watching the videos that you made, that's already very awesome.
Yeah. You also mentioned, or I saw in your videos, that you drop the parachute by using a drone. So parachute drop test with drones is quite a new topic, or like quite a new field that hasn't been done as much. So I was wondering that you could maybe give some tips and tricks for people that are also wanting to give some, or that also want to do drop tests with drones. Maybe there are some issues you encountered.
Yeah. So after flying SC airplanes, I started to fly a bit SC drones. So you don't see all of them, but there are so many drones in my room. And before dropping parachutes, we were actually dropping small SC airplanes with no motor. So you're going up with the drone, and then you're dropping it, and you let it fly.
Like a glider.
Yeah. And the first thing I did was to just make a test using a FPV racing drone. I can bring you one of them. So this one is broken. I will explain later why. But these drones are really strong. Like they are done for racing. They can go maybe 150 kilometers, and you fly them with really big batteries that are just lasting 1 minute or 2 minutes, and each motor can produce up to 1.5 kilogram of thrust. So it can lift a lot, but it is not designed for. So basically, if you're hanging something under it with a long wire or it's gonna start hanging, and it's gonna be absolute chaos. So this was what I was doing at the beginning, and at the beginning the system was like 100 grams or 200 grams, not anything heavier. So it was working quite great. But with the time, everything started to become heavier because I added many things, more battery, a camera, etc., etc. Maybe I can show you the system more precisely after. And it was becoming really possible to use this drone. Then I also add another drone, which is this kind of drone.
Mm-hmm.
So as you can see, it is a little bit bigger, but the problem with this drone is that they are really not designed to produce a lot of lift. So the motor you can get on this drone are designed just to lift the drone and maybe 100 grams of payload, but nothing more. And so this was also really a problem because I was not able anymore to do any drop tests with those two drones. It was too complicated, too hard.
Mm-hmm.
And I've been looking for idea, and I was remembering that at the beginning where drones were becoming more and more popular and were used for sport competition, etc., there were really big drones that were used to lift AV camera. So at that time, GoPros were not really a thing, or they were really filming bad quality.
Mm-hmm.
So you had to have a big camera, and so they had big drones that can lift like 4 or 5 kilograms. And so I've been looking on the internet on one of those, and this is just the propeller of the drone. And so this is the drone that you can see on the last drop test video. And so what is good with it is that it is really designed to lift heavy weights. The bad thing is that you need also really big batteries that cost between 100 and 200 euros per battery. So you have to take this into account. But with this drone, you can do everything. It is also very stable. And one more interesting thing is that this one is like almost 10 years old.
Mm-hmm.
And at the beginning, it was costing maybe 2,000 euros. And now it is only costing 200 euros. So you can, if you look closely on websites that sell things, I don't have the word in English, but already used a bit.
Yeah, like secondhand.
Secondhand. And there are many people that are selling this kind of drones because they are really not useful anymore for the cinema industry, etc. Because there are smaller drones that are better. So yeah, it's really the solution if you want to conduct a drop test from a drone. One thing I have learned is that on this drone, you want to have autonomous capabilities. I mean that the premium solution is that you are able to click on the button. It will go at 120 meters.
Mm-hmm.
You click on the button, it comes back. Because when you're already trying to see what's going on with your parachute, when you are trying to see what's going on with the deployment, etc., etc., if you in the same time have to look at what's going on with the drone, then it's going to be harder.
Yeah.
So on this drone, so it was initially a DJI. So DJI is the biggest brand of drone on the world. And there was a flight controller, but also the flight controller is a bit old. So you might also want to replace it with FPV drone stuff like FPV flight controller and new stuff with open source flight software, etc. They are totally able to do autonomous stuff. So this is really the solution. And yeah, as I say in the video, the transition from this to this was also a transition from black and white versus color. I don't know if we can say that in English too, but that's a thing in French.
I can imagine that it's quite a learning curve, not just on the parachute side, but also indeed on
yeah,
how to fly a drone, how to operate the whole test.
Yeah, and also how to prepare for a test. I've learned how to make a super basic, but how to make a checklist. How to make sure you're not forgetting anything. Also after the flight, how to analyze data, etc. So there was a lot of things to learn, but no, I'm quite happy that this thing are working properly. And
it's great that you get the entire the entire design process, testing process, and everything around it in one project. Such a big learning experience.
Both a big learning curve and learning experience. And an extremely valuable knowledge to have for not just during the studies, but well, for the rest of your life. If you're going to stay in engineering or any other field, probably the first thing you learn when you do any form of experiment is that you forgot half your stuff at home. Especially that one thing that you really needed. So yeah, things like checklists and procedures, that's extremely important.
And also one thing I've learned is that when you're testing something, you want the human, so in that case it was me, to have to make as little thing as possible. So if I have to connect many things, if I have to build many things on site, it is almost sure that something is going to fail. So if I can give an example on the system, so this thing is really, really helpful. It changed many things because many times I did a drop test with a drone and I was so stressed that so the system was attached behind under the drone, and so I'm dropping it with the drone. I'm waiting it to deploy the wing, waiting, nothing. It goes into the ground. I'm like, again, it failed. I go to see what happened, and just it was not powered down. So, as many human steps, it means that like, I have done everything. And so this is also one of the things this project learned me. You have to, if you have only one thing to do, it's perfect.
Yeah, the more you can reduce the amount of steps that you have to do, or the connectors you have to attach, or well, whatever, the more steps you have, the more room for error you have.
Yeah.
That sounds very familiar.
Do you also think that in some point in the future, if you would have to continue the project, that you would use the same system to deploy a bigger parachute, bigger parafoil or glider, or would you like to stay within the smaller regimes of parachute?
So I don't even really know how I have chosen this size. Maybe, yeah, that's really good question. Maybe the size factor was to make it fit in a model rocket. But it is also very interesting on a bigger size because it means you can transport and guide a bigger payload. And it is very interesting because bigger payload mean more money, so you want to recover it.
Yeah.
And also with bigger wings, it is a bit more simple to steer them because they are how to say it, I mean, they are less moving in any direction. At
They're
the
more
moment,
stable.
yeah, they are more stable, and when you turn, they are turning slowly, so you have the time to get your data and get your control loop. So it is a bit easier. But then the problem is you need an helicopter every time you want to
Then it gets expensive rather quickly.
Yeah.
And probably also when you have a bigger canopy, at least what we saw with ballistic parachutes, the bigger your canopy, the less influence production errors have, or error in line lengths or things like that. So everything becomes a bit more
forgiving.
Yeah, it's a lot harder in operations, and what you say, you need a bigger drone or helicopter or whatever you're dropping it from. Then, yeah. So some things might be easier, sometimes might definitely be more harder.
But what I can say is that if you want to reduce the size, it's going to be hard.
Yeah.
I think that I'm already at the. If you take a look at the system, there are things that you can't really make smaller. Again, for example, you need a servo motor to control to steer the wing, and it's already taking maybe 95% of the diameter of the tube. So it's going to be harder to make it smaller, but it can definitely be made bigger.
Yeah. Yeah, there is also a lower limit where it has to still physically fit, inside your vehicle.
Yeah.
Yeah, it's a really interesting project. Yeah.
Definitely, I'll keep an eye on in the future to see what is happening on your YouTube channel.
Yeah, I'm going to try to make few other videos where I explain a bit more. I mean, videos where I talk. But
nice.
Yeah, it's also something I'm learning, and yeah, it's quite difficult to make sure you're explaining things the right way and people are gonna understand you. And also, I'm not English, and you guys know that we French don't speak well English, and I'm sure you have already seen it. And so it's quite difficult too. But I think, it's important to share the story and explain why I'm doing this, and also because I have to give a little bit back to people who are supporting the project. So it's important to make these videos, and I will continue to make them.
I would look forward to those videos. I would want to see them. But I mean, we can perfectly understand you. So that's
yes.
I mean, what I also said in the email, your English is better than my French. So
definitely. Yeah. So apart from the YouTube channel, where can people follow your story or your flights?
So what I'm trying to do is that so I'm posting big updates on the academy.io page. So it's like a place where projects can be created, and then there are page, and then there are project logs, so you can follow in the long term the project. There are also place for file, etc. But on shorter term, I'm trying to publish as frequent as possible updates on a Twitter thread. So like I try to post something every day or every 2 days about the project. And as soon as there is a new test flight, I'm posting a shorter video, etc. And that's it for the moment. And so, the YouTube channel for longer videos and longer test flight videos, and the academy.io page for longer recent updates, and Twitter for smaller updates and sometimes smaller jokes.
Great. I'm looking forward to see everything.
We'll be sure to link them in the video as well, so people can find them.
Definitely.
Perfect. Thank you.
Do you have any questions, Thomas, or anything you want to still add, Yohan?
Well, when you're working on such a project, sometimes you are taking like the wrong path.
Yeah.
And and it's hard to know if it is the right path or the wrong path. And maybe one idea was to show all the wrong paths I took to show that yeah, it's really a thing, and you have to take those wrong paths. This is something that I like to show.
Yeah.
So one day this is how the system was looking like, and today this is how the system is looking like. So you can see that there is a big difference. And so if you take a look at what people do with SC paraglider, they are using it like for fun with a motor. And after being able to deploy the parafoil wing, the ram air canopy, I thought it would never be able to do the same with the paraglider. Finally, it was possible, but at that moment I was not sure. And the project took an interesting turn, which was that, well, if I'm not able to solve this problem, maybe I'm gonna do something absolutely different, which was to, instead of doing drop tests, would be to just fly the paraglider wing autonomously with a motor. But like that would mean impossible on a model rocket and very difficult on a weather balloon. But that was a bit the only solution I had. And all this to say that it was working great with this motor, but in the end, well, I'm saying things that are, I'm having trouble to express them in English, but I was thinking that something will be very hard or impossible without even really testing it.
Yeah.
And without really testing it, I was taking the wrong path. So if you have two ideas of you're facing a problem and you have two different paths, the only thing you have to do is to test everything. And if it is necessary, to fail on everything. And so I think this is something important that this project learned to me. And now when I have few different paths to take, I try to test them all. And this is what brought me to this system. This is what brought me to what is working today. And I think this is what is also important with this project.
Yeah, exactly. You said it's a wrong turn, but you only know that something is a wrong turn after you tried it, or that you prove that something else is better. It's not weird in engineering to have multiple solutions or multiple concepts and not be completely sure which one is the best. And also the best is usually defined by so many parameters that it might be a bit more expensive but better in flight, or a bit less good in flight but a lot cheaper or easier to deploy. So it's sometimes maybe the wrong turns can be even more interesting or more of a learning experience than the right choices or right choices.
And sometimes I am also a bit afraid because you find a new idea and you see that there are so many different paths that you can take, and it can be a bit complicated because you always want to be sure you're taking the good path. And sometimes you're starting like 10 different things to explore everything. But yeah, you have to test to see if it's good enough, and this is the only way to know.
And sometimes you move forward into testing and detailed design, and you have the system ready, and then you start doubting if the other concepts might have been better or easier. It's a lot of second guessing, and especially if you have the nights before a test or the days before a test, then you start doubting every choice you made in the last year.
Absolutely, yeah.
No, what I'm doing the day before is that I'm really getting all the idea the day before, because I'm putting everything in docs, and I'm taking a sheet of paper and I'm writing everything. And then the day after, I'm comparing between what I have wrote the day before and the day after, and all the ideas are there. And this is the best way I have found to get the right idea or to solve the right problem and go forward.
Yeah, I think that's a really smart thing to do, is just to write everything down, and then afterwards, when you're a bit calmer, compare them to what happened, and then to think about them again.
I like the part where you write it down, because usually you think about it, but if you actually write it down, then you can prove yourself how wrong you were or how different.
Or maybe there's a great solution there to a problem you didn't know you had.
And sometimes you even have to tell your ideas to other people to find how wrong they are. And this is something that is really hard with this project, is that at the moment I'm a bit alone, and it will be great to find a project mate, someone who was willing to work on this project too, because I think it's really helpful to be at least two to tell to the other when his idea is really wrong, or at least in our opinion. And it might be also a bit helpful to take a step back on the project and see, okay, what are we doing now?
Yeah, and also just to be able to, if you can explain your problem and if you can explain your solutions, then usually, if you can't explain it, then you don't understand it completely.
Yeah.
It's indeed quite often also in the past few years where we discussed problems, and halfway, describing the problem, you find your own solutions or your own pitfalls. So yeah, I think the call for more cooperation in the high school, university, parachute field in Europe is definitely valid. I think we're all facing the same problems, or we're not yet aware that we're going to face those problems, and people can help with that. So yeah, I think that's a very valid point. Did you have anything else, Thomas, or anything?
Nothing related to the project, at least.
What else did you have?
Many issues, but yeah, let's not go there.
Okay, I think it's quite good.
How about you, Yohan? Do you still have some questions for us, or some remarks?
No, I think we almost covered everything. Then there are small details, but I mean, it should be a generic video, not a ultra specific video. I don't know what your audience is, but I guess they like parachutes, but
yeah, it really varies. I mean, we're not active on YouTube yet, so we don't really know how that is going to go. But on Twitter, we see engineering enthusiasts to people who work in the EDL field. It's quite broad. But you should also leave some content for your own videos, of course. I mean, we're going to be watching your YouTube channel now.
Definitely.
Yeah. There is a good community of people interested in space and on the internet, and it's quite cool because, like, I see many people with incredible projects, and for me, there is a lot of inspiration, and these people are also giving good feedbacks, and yeah, the internet could be a very great place today.
Yeah, I completely agree with that. I want to thank you very much for tonight. I think we saw quite a lot of cool stuff, and we want to wish you all the best with the project, but also with your studies in the upcoming year. And
good luck with those.
Hopefully you can continue the project, and we get to see a lot more awesome videos soon.
Yeah, thank you for having me. And whatever happens, I will keep you updated on YouTube or on the internet. And I hope I hope one day we can talk again about the first space mission or something that is really working.
Yeah, I mean, it will be very nice.